A-level statistics, averages and spread. This is an exercise on variance and standard deviation. Now this is an exercise. Pause the video at this point and have a go at the questions. When you've finished, restart the video and I'll go through the solutions. In part 1, we're asked to calculate the mean, the variance and the standard deviation of the following numbers: 4, 8, 12, 6 and 11. Now to solve this, the first thing we notice is there are 5 numbers, so n equals 5. We then need to work out sigma x, that's the sum of the numbers: 4 plus 8 plus 2 plus 6 plus 11, and that's 41. Now the mean is the sum of the numbers divided by the number of numbers. So that's 41 over 5, which is equal to 8.2. So the mean is 8.2. Now to find the variance, we also need to know the sum of the numbers squared, that's sigma x squared, which is 4 squared plus 8 squared plus 12 squared plus 6 squared plus 11 squared, which is 16 plus 64 plus 144 plus 36 plus 121, or 381. Now the variance is sigma x squared over n minus the mean squared. So it's 381 over 5 minus 8.2 squared, which is 76.2 minus 67.24, which is 8.96. So the variance is 8.96. Now the standard deviation is the square root of the variance. So it's the square root of 8.96, or 2.9933. So the standard deviation is 2.99, rounded off to 2 decimal places. Now in part 2, we're asked to find the mean, variance and standard deviation of a second list of numbers: 3, 8, 5, 7, 3, 6, 8 and 11. Now the first thing to notice is that there's 8 numbers, so n is equal to 8. We then have to find the sum of the numbers. So 3 plus 8 plus 5 plus 7 plus 3 plus 6 plus 8 plus 11 is equal to 51. Now the mean is the sum of the numbers over the number of numbers, which is 51 over 8, or the mean is 6.375. Now to work out the variance, we need the sum of the numbers squared, sigma x squared. Now that's 3 squared plus 8 squared plus 5 squared plus 7 squared plus 3 squared plus 6 squared plus 8 squared plus 11 squared, or 9 plus 64 plus 25 plus 49 plus 9 plus 36 plus 64 plus 121. And that's 377. Now the variance is the sum of the squares of the numbers divided by n minus the mean squared. So it's 377 divided by 8 minus 6.375 all squared, or 47.125 minus 6.375 squared. And that turns out to be 6.484375. So rounding it off to 2 decimal places, we have the variance is 6.48. And to find the standard deviation, we simply take the square root of the variance, which is equal to 2.5464, and so the standard deviation rounded off to 2 decimal places is 2.55. Now in part 3, we're asked to find the mean, variance and standard deviation of some group data. We've got the numbers 4, 5, 6, 7 and 8 with frequencies 6, 3, 2, 5 and 4. Now it's a good idea to draw a more complete table. So I've drawn X and F as columns and extended the grid. Now we've got 6 4s and 3 5s and 2 6s and 5 7s and 4 8s. So altogether the total number of numbers is the sum of the frequency column. That's 6 plus 3 plus 2 plus 5 plus 4, which is equal to 20. So sigma f is equal to 20. We now need to get the total of all the numbers. Now that is 6 4s plus 3 5s and so on. So it's the sum of the number times the frequency, or xf. So we create a column labelled xf and we multiply 4 times 6 to get 24, 5 times 3 to get 15, 6 times 2 to get 12, 7 times 5 to get 35, and 8 times 4 to get 32. We then add those numbers to get the total sum of all the numbers, and that comes to be 118. So sigma xf is equal to 118. But we also need the sum of the x squared f, so we add another column for x squared f. That means we square the x and times it by the f. 4 squared times 6 is 96. 5 squared times 3 is 75. 6 squared times 2 is 72. 7 squared times 5 is equal to 245. And 8 squared times 4 is 256. We then total those up to get 744. So sigma x squared f is 744. So we've got the mean is sigma xf over n, which is 118 over 20, or 5.9. And that's our answer. The mean is 5.9. For the variance, we want sigma x squared f over n minus sigma xf over n all squared, or sigma x squared f over n minus the mean of x all squared. So that's 744 over 20 minus 5.9 squared, which is 2.39. So we have the variance is 2.39. And the standard deviation is the square root of the variance, which is 1.54596. So rounding it off to 2 decimal places, the standard deviation is 1.55. Now in question 2, we're given a table and we're asked to calculate an estimate of the mean, variance and standard deviation of the group data. Well, we can only calculate an estimate because we don't actually know what the numbers are. We only know that there are 9 numbers somewhere between 0 and 10, and 21 numbers somewhere between 10 and 20, and so on. Now we're going to make an assumption that the mean of the numbers in each group is equal to the mid-value of the upper and lower limit of the group. So to solve this, we first need a larger table. Then we need to know how many pieces of data there are. So we must add the frequencies. Sigma f is the number of pieces of data, which is 9 plus 21 plus 35 plus 10 plus 5, which is 80. We then have to work out what the group mid-values are. So the mid-values are 5, 15, 25, 35 and 45. And taking the mid-value of each group as an estimate of x, we want the sum of each mid-value times its frequency. That is the sum of each xf. We say we've got 9 with the value 5, 21 with the value 15 and so on. So we work out 9 times 5 is 45, 21 times 15 is 315, 35 times 25 is 875, 10 times 35 is 350, and 5 times 45 is 225. And that gives a total of 1810. So sigma xf is 1810. And then finally we need to find the sum of x squared f. So we have a column for x squared f, and that means we take the value of x, square it, and then multiply by the frequency. So we have 5 squared times 9 is 225, 15 squared times 21 is 4725, 25 squared times 35 is 21,875, 35 squared times 10 is equal to 12,250, and 45 squared times 5 is 10,125. Now if we add all of those together, we get 49,200. Now, the mean is the sum of the xf over the sum of the f, which is 1810 over 80, or 22.625. And so the mean is 22.625. Now the variance is the sum of the x squared f over the sum of the f, minus the sum of the xf over the sum of the f, all squared. Now that is 49,200 over 80 minus 1,810 over 80 all squared, which is 615 minus 511.8906, which is 103.10937. So rounding it off to 2 decimal places, the variance is 103.11, and the standard deviation is the square root of that, which is 10.1543. So rounding that off, we get the standard deviation is 10.15. Now in question 3, we're told that the mean of a set of 7 numbers is 4, and the standard deviation is 2. The number 10 is added to the set. What are the new mean and standard deviation? Well, first of all, we've got n is equal to 7, x bar, that's the mean, is equal to 4, and the standard deviation is 2. Now we know sigma x over n is equal to x bar. The sum of the numbers divided by the number of numbers is equal to the mean. So sigma x over 7 is equal to 4, sigma x is equal to 28. In other words, the sum of all the numbers is equal to 28. Now we know the variance is equal to the standard deviation squared, which is 2 squared, or 4. And we also know the variance is equal to sigma x squared over n minus the mean squared, x bar squared. So, sigma x squared over 7 minus 4 squared is equal to 4. Sigma x squared over 7 minus 16 is equal to 4, so sigma x squared over 7 is 20, or sigma x squared is equal to 140. All the terms squared and added come to 140. Now we add an extra term 10. And this gives us n is equal to 8. Before we had 7 numbers, now we've got 8. The sum of the numbers used to be 28, but we're adding an extra term 10, so the sum of the numbers now is 38. Now we had the sum of the numbers squared was 140, but we're adding 10, which when squared is 100. So we've got 140 plus 10 squared, which is 240. The mean is the sum of the x over n, which is now 38 over 8, which is 4.75, so that's our answer. The mean is 4.75. The variance is the sum of the x squareds over n minus the mean squared, so that's now 240 over 8 minus 4.75 squared, which works out to be 7.4375. But we want the standard deviation, which is the square root of that, which is equal to 2.727178. Rounding that off, we have the standard deviation is 2.73. Now in question 4, we're given a set of data with the sum of the numbers equal to 143. So sigma x is equal to 143. The sum of the numbers squared, sigma x squared, is equal to 580, and the standard deviation is 4. We want to find the number of terms in the data. Well, to solve this, let the number of terms be n. Now we have the variance is equal to the standard deviation squared, which is 4 squared, or 16. And the variance is the sum of the x squared over n minus the sum of the x's over n all squared. So that's 16 is equal to 580 over n minus 50 over n all squared, or 16 is equal to 580 over n minus 2500 over n squared. Now if we multiply all the way through by n squared, we get a quadratic in n. We can put all the terms over onto one side, and we can divide all the way through by 4, and that gives us 4n squared minus 145n plus 625 is equal to 0. Now we can't really factorise that, so we're going to have to use the formula to solve it. So using the quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. We substitute in a is 4, b is minus 145, and c is 625. That gives quite a long expression, but it does simplify down, and it comes to n equals 145 plus or minus 105 over 8. And so n is equal to 31.25 or n is equal to 5. But since n is the number of pieces of data, it has to be a whole number. So the only solution valid is the number of terms is equal to 5. And finally, question 5. We're told that in a class of 30 students there are 18 boys and 12 girls. The mean weight of the boys is 68 kilograms and the mean weight of the girls is 54.6 kilograms. The standard deviation of the boys' weights is 5.8 kilogram and the standard deviation of the girls' weights is 3.6 kilograms. In the first part we want to find the mean weight of the class, and in the second part we want to find the standard deviation of the weights of all the class. Now to solve this, let's represent the weights of the boys by x and the weights of the girls by y. Also, let's represent the weights of the class with z. Now, the mean of the boys' weights, that's x bar, is equal to 68, which means the total weight, sigma x over 18, is equal to 68. If we multiply both sides by 18, we get sigma x is equal to 68 times 18. In other words, the sum of all the weights of the boys is 1,224 kilograms. Now we can do the same with the girls. Y bar, the mean weight of the girls, is 54.6 kg. So, sigma y over 12, the total weight of all the girls divided by 12 is 54.6. Multiplying both sides by 12, we get sigma y is equal to 54.6 times 12. The total weight of all the girls is 655.2 kg. Now, if we consider the whole class Z, we've got Z bar is equal to sigma Z over 30. The mean of the class marks is the sum of the class marks over 30. That is 1,224 plus 655.2 over 30, which works out at 1,875.2 over 30, or 62.64. So the mean weight of the class is 62.64 kg. Now to work out the variance of the whole class, we need to work out what sigma x squared is and what sigma y squared is. And to do this, we can start with the standard deviation of the boys, SDX, which is equal to 5.8. So the variance for the boys is 5.8 squared, which is 33.64. Now we know sigma x squared over n minus the mean squared is the variance, so it's equal to 33.64. So sigma x squared over 18 minus 68 squared equals 33.64, or sigma x squared is 18 into 4,624 plus 33.64, which is 83,837.52. Now we can do the same with the girls. The standard deviation is 3.6, so the variance is 3.6 squared, which is 12.96. Now the sum of the y squareds over n minus the mean squared is equal to 12.96. So the sum of the y squareds over 12 minus 64.6 squared is equal to 12.96. So sigma y squared is equal to 12 into 2,981.16 plus 12.96, or 35,929.44. Now, the variance of z is equal to the sum of the z squared over n minus the mean of z squared. That's equal to 83,837.52 plus 35,929.44, all divided by 30, minus 62.64 all squared, which works out to be 68.4624. Now, the standard deviation is the square root of the variance, and that works out to be 8.2742. So rounding it off, we get the standard deviation is 8.27 kilograms.